All right, guys. Hello and welcome to Calculus BC. Today we will begin our study of calculus in Chapter 2 of our Larson book that we use here at Reedy High School. I'm skipping Chapter 1. That is just material that you study in pre-calculus. So if you were at Reedy, you should have already covered it. So we're going to go ahead and jump straight to Chapter 2, which has to do with something called a limit. Now, it is very important for you to understand. I'm going to emphasize this. It is very, very, very important for you to understand the limits are the foundation to calculus. It is a very, very important skill for you to learn. We're going to move through it rather quickly, but I want you to know that I'm going to reference back to limits constantly throughout the year. So please make sure that you study them and that you give yourself time to fully comprehend them, as they are such an important skill moving forward. Okay, so let's go ahead and get started. So go ahead and minimize this. So we'll start with section 2 of the book, which has to do with limits graphically and numerically. So first of all, we need to understand what a limit is. So here's the definition of limit. If f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. Okay, so what does all this mean? First of all, let's take all these words. You gotta remember here, we in mathematics, are very lazy. Instead of writing all of this, we can come up with some type of expression to write this mathematically, and that's what we're gonna do, right? So what all of this is saying is, I'm gonna go ahead and translate this. It says the limit as x approaches c. So the limit of f of x as x approaches c is L. So the limit as x approaches c of a function, so you have to be given a function, is equal to L. Now we're calling it L just because of a limit, right? So this right here is a translation of that, right? So it's just written in very, very short format instead of writing all these sentences. But what does this really mean? Okay, so the easiest way to understand limits is to start out with a graphing approach so that you can dissect what this means. So that's what we're going to do. So let's take out an example, and let's say that you are asked to find the limit as x approaches 1 of x to the third minus 1 divided by x minus 1. Okay. As of right now, you've never seen limits before, so you don't really know how to attack this. You haven't been taught how to attack this. So the first thing we're going to do is we're going to come up with a graph of this, and we're going to go back to this definition to see if we can understand what's happening. So I'm going to go ahead and use my graphing calculator that I have here. So I'll just clear it out so you guys can see. So we're going to go in here, and I'm going to graph this function that was given to me. So we got x to the third power minus 1 divided by x minus 1. And I'm just going to go ahead and hit graph. And it'll eventually get there. And there we go. So here's what it looks like. So I'm going to go ahead and zoom in for you guys a little bit. Turn that off. And that actually didn't help, so let me turn it back on. Here's what it looks like. Okay, so let's kind of talk about what this means. I'm going to use this, and I'm going to actually sketch it on the paper so you guys can see a little bit better what I'm talking about. So here's my y-axis, here's my x-axis. I'm just going to plot some points, right? So according to this, I should have a point at 0, 1. And then I have one error. We'll talk about that here in a second. 2, 7. So 2, 7. So 1, 2, 7 would be like 1, 2, 3, 4, 5, 6, 7, like way up here. 3, 13, it gets higher. So let's see, negative 1, 1. So negative 1, 1. And then what else? We got negative 2, 3. And that's really all I need. I'm going to go back to this thing, and it looks like, from the looks of it, it's going to go down here, it's going to go up here, it's going to go here, and then it's going to go that way. So that's kind of what it looks like. Now, let's talk about this real quick. I'm interested in why we got this error here. Okay? I want you to think this through. The first way you learn how to graph is just to plot points into a function. So if you remember, back in Algebra 2, if we plug in 1 here, that's going to give you a 0 in the denominator. Getting a 0 in the denominator means that it's going to be undefined. Now, I'm going to getting ahead a little bit of myself, but through the algebra, if you remember when you were graphing rational functions, you were told how to find a whole. So really what's happening is my calculator is not showing me this. Let me see if I actually can zoom in and maybe it'll show it, but I don't think it will. But let's see what happens. So as I zoom in on the calculator, it's taking its time. Yeah, no, it's hard to see. But what's happening is that actually at this value of 1, so here's 1, what is happening here is that we actually have a whole. So you remember discussing wholes back in Algebra 2 or Algebra 1. I think it's Algebra 2. Okay. Now the question is here, okay, so there's a whole, which means that there's not a point there. So what does that mean as far as my limit goes? Well, let's go back and analyze the situation. Okay. The definition says, if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c from is L. Okay, so let's talk about what everything means. Okay, c, if you go back to here with the translation, c for us would be the 1, right? So it says, as you approach c. Now notice how the definition is as you approach c from either side. So what does that mean? From either side, that really just means from left and right. So if you analyze this, left and right would be like, if you are approaching, if you were, pretend you're walking on this graph, and you were actually on this graph, and you were walking along this graph, then you would be coming this way, right? And your friend is actually walking on this side, and it would be coming on this side, right? But notice how you guys are both approaching this one value right here, which we're going to call c, which in your case, it's 1. So as you're approaching from either side, if you're approaching a unique value, so it says if you get arbitrarily close to a unique value, so in this case, this value right here that you're approaching, this right here, has to be a unique. Now, why is it unique? It's because you both are arriving at the exact same, it's a unique location. So the question is, what is this value here, right? Now, it's kind of hard to see there from our picture, so let's see if we can use our calculator to help us out. Now, I'm going to go ahead and zoom back out. So zoom 3, zoom back out. And we're going to see what happens here. Sorry, it's taking a little while. Okay, here we go. So what I'm going to do is I'm just going to hit trace. I'm just going to move my cursor. Trace. I'm just going to hit my cursor along the line. Now, I want you to look at the x value here. So I'm going to go ahead and zoom in. The x value that we have here. So, let me out of focus. I'm going to try to focus again. Alright, there you go. Notice, I'm going to be switching it off. So, what I'm interested is on the y value. So, as I'm approaching, so that's 0.15, 0.3, 0.45, 0.6, 0.7. So, notice how x is getting close to 1, which is what I want to do. Let's see what the y is getting close to. So, 0.99. Okay, notice how it jumped from 0.9 to 1.06, but notice it jumped from 2.73 to 3.18. So my guess here is that we're approaching 3. I'm going to go ahead and say that the limit as x approaches 1 of x to the third minus 1 over x minus 1 is going to equal to 3. Okay, now you may be like, well, how are you sure about that? Okay, so first, we should be able to look at a graph, right? So that was, look at the title, graphically. The other way is to do it numerically. So what does that mean? Okay, to confirm, I'm going to use the exact same example here. Numerically would be like, hey, why don't we use the tables to help us out? So let's go back. So we have the same thing here, but now I'm going to go to the table. So I'm going to go second table. Now, notice how my table, go ahead and go back in there again. Notice how my table, it's going by ones, so it's really not helping again. It's got that error there. So what I'm going to do is I'm going to go to this second table set. I'm going to do a couple changes. Okay, this little triangle means change. So it's right now the table is going by ones. 1, 2, 3, 4. So what I'm going to do is, let's say, what happens if I do, I don't know, by 0.5, and I go back to my table and I'm going to start it up at 0. So I'm going to go to the table. So now notice how your table is going by halves. So once again, it goes like, as you're approaching 1, so as I'm approaching 1 from the negative numbers and the positive numbers, once again, now I got a little better. It says, hey, you go to 1.75, but then from this side is 4.75. I'm not quite sure I like this. So the best way to improve this is to go back to that menu and make this even smaller. So to save you time, I'm going to go ahead and go small. So I'm going to exaggerate a little bit, 0.001. It's very, very small steps. So I'm going to go back to the table, and look at that. You see how it's a little bit better, like you can see the white changing. Okay, so now I don't want to scroll this 100 times. I'm going to go back here, and I'm going to say, what do you want to start? Well, let's start at 1. That's where I'm interested on. Okay, so here we are. Notice how I'm still getting an error, but look at this table. This table's a lot better. This table allows me to see things. Look, as I'm coming from the negative numbers, right? So 0's that way, right? As I'm approaching 1, notice how it's 2.91, 2.994, 2.997, right? So it seems like it's getting closer to 3. Now the other way, as I'm approaching from this side, it's going down 3.09, 3.06, 3.003. Now, I personally am convinced that I am in fact approaching 3. If you're not convinced, then you can always go back to here and go even smaller, 0.0001. And once again, let's hit 1, and we'll see what happens. And once again, I am without doubt sure that the limit is 3. Okay, so let's kind of talk about this real quick. That was a very, very quick example, but I think it's an example that you guys can understand, and you should be able then now to, after watching this video, to successfully use a graph to estimate a limit, or use a table to estimate a limit. Okay, hopefully you also understand the definition of a limit by this point. If you have any questions, please make sure that you don't hesitate to ask me, as I am available to answer those questions for you. Thank you for watching, and we'll see you next time.